Hello engineers, welcome to the back channel. In today's video, we'll tackle an exciting mathematical challenge, calculating the area enclosed between two fascinating curves. The curves we'll be working with are y squared equals 4x, a parabola that opens to the right. X squared equals 4y, a parabola that opens upward. Our mission? To determine the total area of the region enclosed between these two curves. Let's dive in and break it down. First, we'll analyze the shapes and intersections of these curves to better understand their geometry. We first determine where these two curves intersect. We solve y squared equals 4x and x squared equals 4y simultaneously. From y squared equals 4x, take square on both sides. We get y square of square equals 4x squared. Next, y to the power of 4 equals 4 squared x squared. Next, y to the power of 4 equals 4 squared is 16, then x squared. Next, y to the fourth power equals 16, then substitute x squared equals 4y. Next, y to the fourth power equals 16 into 4 is 64, then y. Then, I to the power of 4, now 64y, it goes to the left-hand side, minus 64y, equal to 0. Now, take a common element y, then we get y into y cubed minus 64 equals 0. Now, multiplication of two factors equals 0, then y equals 0, and y cubed minus 64 equals 0. Here, 64 goes to right-hand side, y to the power of 3 equals 64. Then 64 rewrite 4 power 3, now y cubed equals 4 cubed. Here both sides powers are equal. Assume that base are equal, then y equals 4. Now, y equals 0 and y equals 4. Substitute any one of the equations. Now, take x squared equals 4y, then substitute y equals 0. Then x squared equals 4 times 0. Then x squared equals 0. Also, x equals 0. Again, substitute y equals 4. Then x squared equals 4 times 4. Then x squared equals 4 squared. Also, x equals 4. Thus, the points of intersection are 0, 0 and 4, 4. Now plot the points 0, 0 in the curve and 4, 4 in the curve. Let's take a vertical strip in the closed region. Now, let's set up the integral using a vertical strip in the enclosed region. A vertical strip moves from left to right across the region. We first determine the range of x values. The region starts at x equals 0 and ends at x equals 4. So, x varies from x equals 0 to x equals 4. For a fixed x, the strip extends from the lower curve to the upper curve, meaning we integrate in terms of y. From lower curve change in terms of y, let x squared equals 4y. Then y equals x squared divided by 4. Again, take upper curve in terms of y. E squared equals 4x. Then y equals square root of 4x. Now y equals 2 square root of x. So, y varies from y equals x squared divided by 4 and y equals 2 root of x. The region bounded by x equals 0 and x equals 4, and for each x, y ranges from x squared divided by 4 to 2 root of x. The area A can be written as area equals integral 0 to 4 integral x squared divided by 4 to 2 roots of x dx. The inner integral is with respect to y. When integrate di, we get y. We substitute I for upper limit. 2 root of x minus, substitute I for lower limit, x squared over 4. Integral 0 to 4 2, then root of x written as x power 1 by 2, then x squared divided by 4 dx. Then integral x power 1 divided by 2, we get x power 1 divided by 2 plus 1 divided by 1 by 2 plus 1. Again integral x power 2, we get x power 2 plus 1 divided by 2 plus 1. One by 2 plus 1, we get 3 by 2, and then 2 plus 1, we get 3. Now, 3 by 2. Go for reciprocal, then multiply 2 by 3. Next 4 into 3 is 12. Now 2 into 2 equals 4. Now substitute x for upper limit, 4 power 3 by 2 and 4 power 3 minus. Then substitute x for lower limit, 0 power 3 by 2 and colon 0 power 3. Four. Rewrite 2 power 2 and 4 power 3 is 64. 0. Multiply any number 0 and again 0. Multiply any number 0. 2 power 2 power 3 by 2. Simplify, we get 2 power 3 and 64 divided by 12. Simplify, we get 16 divided by 3. Two power 3 multiply 4, we get 32 divided by 3. Denominator are equal, then subtracted numerator. Thus, 36 minus 16 equals 16. Hence, the area is 16 divided by 3. Thank you all. If this helped, please like, subscribe, and hit the notification bell for more math content. See you next time.